Well, hey everybody, Mr. Reeves back with you. And today in this video, we are looking at lesson 18.2 in the Accelerated Math 7 textbook, brought to us by HMH, Equations with Rational Numbers. All right, so we've done one-step equations. We've done two-step equations. Our last equations we solved were equations with variables on both sides. Now we're going to look at equations with rational numbers. All right, so hopefully you remember from our study of numbers earlier this year that a rational number is any number that can be written as the ratio a over b, or the fraction a over b, where a and b are integers and b is not equal to 0. All right, so pretty much when I say rational number, you should think fraction or decimal. Usually when we say rational, we're not referring to whole numbers or positive and negative whole numbers, which we call integers, or whole numbers and their opposites, which we call integers. Usually when we say rational numbers, we are saying specifically we're going to be working with fractions or decimals. Of course, we all know that rational numbers written as decimals must either terminate or repeat a pattern. All right, but I digress. Let's go ahead and start with looking at an equation that involves fractions. So if you look here at example 1, which is on page 565 in the textbook, which I referenced earlier, here we go. We have 7/10 n plus 3/2 equals 3/5 n plus 2. So you can see we have an equation with variables on both sides. Okay. So one option would be to say, okay, well, I've got all these fractions. If I'm going to add or subtract, I need a common denominator, right? So I could say, well, what's the common denominator for 2 and 5 and 10? Remember, the common denominator, or in this case, what we're looking for is the least common denominator, which would be the least common multiple, is the smallest number that they all are factors of. Well, 2 goes into 10, and 5 goes into 10, and 10 goes into 10. So the least common denominator would be 10, right? Because 2 times 5 is 10, and 5 times 2 is 10, and 10 times 1 is 10, right? So one option would be to say, okay, well, that one's already good. I've got 7/10 n plus, well, now this number here, 3/2. Well, 3/2, if I want to put that over 10, I could say, well, that was what, times 5, right? So I need to do this one times 5, and 3 times 5 is 15. So this would be 15 over 10, 15 tenths. I think that's what I was trying to say. All right, and then I have 3/5. Okay, and again, I want the denominator to be 10. Well, 5 goes into 10 2 times. 3 times 2 is 6. So this would be equals 6/10 n plus, and of course this 2, we weren't thinking of 2 as a fraction, but you can take any whole number and put it over 1. 2 over 1, if I want that denominator to be 10, that's times 10 times 10, and I would get 20 over 10. All right, and then I have an equation where I have all common denominators, right? And then I could work with it that way, right? So if we were to go here, let me write it down here. 7/10 n plus 15/10 equals 6/10 n plus 20 over 10, right? Well, what do we do when we have variables on both sides? We subtract, right? We subtract this. We find the coefficient of the variable that's smaller, and we subtract it. Do you agree that 6/10 is smaller than 7/10, right? And I would subtract 6/10 n, right? And then that leaves me with what? 1/10 n? What? Not 1 over n, Mr. Reeves. 1/10 n plus, man, I'm having all kinds of problems this morning, plus 15/10 equals 20/10, right? And then what would I do? Okay, well, now I have a two-step equation, right? So now I'm going to subtract 15/10 from both sides. All right, and then I guess I'm doing this That cancels. And then I get 1/10 n equals, well, 20/10 minus 15/10 is going to be 5/10. All right, but my goal is to get the n by itself. What is the opposite of multiplying by 1/10? It's dividing by 1/10, right? So I divide both sides by 1/10. All right, and 5/10 divided by 1/10 is going to be 5. All right, if you didn't know that, remember dividing by a fraction is the same as multiplying by its reciprocal. So 5/10 divided by 1/10 is equivalent to 5/10 times 10 over 1. Those 10s cancel and you get 5. Okay, so that is a perfectly acceptable way to do it, okay? But wouldn't it be nice if there's an easier way? All right, the more fractions we deal with, the more likely we are to make a mistake. Now, let's take a look at how the book did it. All right, if you take a look, they started at the beginning in the same way we did. They found the least common multiple, or the least common denominator. They call it the least common multiple of the denominators. All right, so the least common multiple, or sometimes we call it the LCD, the least common denominator. But instead of making everything have that denominator 10, can you see what they did here? They multiplied both sides of the equation by 10. Now remember, we're allowed to do that, right? As long as we do it to both sides of the equation, this would be an example of the multiplicative property of equality. So instead of making all the denominators 10, they multiplied everything by 10. All right, 10 to the first term, 10 to the second term. You'll see that they applied our favorite distributive property, right? And then 10 to that term, and then 10 to that term. So by multiplying everything by 10, and they show all their work here, you can see we now have this equation here. So here is our original equation, right? And here is our new equation. So here's our original equation. And then down here is our new equation. Now, if I were to ask you and give you a choice, do you want to solve that top equation or that bottom equation, right? Most of you would say, well, Mr. Reeves, I'll solve that bottom equation. It looks a lot easier. There's no fractions. But remember, those two equations are equivalent to each other in that, well, not equivalent. They're not equivalent equations, but they're both true, and the solutions will be equivalent. The solutions will actually be the same. When you multiply or divide or subtract or add to both sides of an equation, if the original equation was true, the second equation is true. And even though the equation is different, the solution will be the same. Do you remember the solution we got when we did it with the fractions? Do you remember that? We got an answer of 5, right? You guys remember we got an answer of 5? All right, now take a look in the textbook here. There it is. They solved that new equation, this equation right here, right? They subtracted 15, all right, and then they got n is equal to 5. Much, much easier to solve. Okay, so to summarize, what we're going to be doing is taking an equation here, this first one with fractions, and later we show you it works also with decimals. And instead of finding that common denominator and making them all have that common denominator and then doing some real yucky looking math with lots and lots of fractions in it, all right, instead of doing that, what we're going to do is we're going to multiply by that common denominator and get it to an equation that is less yucky, right? Less yucky equation. And we do that by multiplying by the least common denominator, or as the book said, the least common multiple of the denominators. All right, so let's do a couple more examples here. All right, this one's actually a little easier because if you look at the denominators, all right, I'm going to put a 1 there and a 1 there. You see that our denominators are 1 and 7. So we're looking for the least common denominator for 1 and 7. And what is the smallest number that 1 and 7 are both factors of? What's their least common multiple? It is 7. So what are we going to do? We're going to multiply both sides of the equation by 7. All right, we're going to distribute that 7 through everything. Here we go. Now, 7 is the same as 7 over 1. So that 7 and that 7 cancel. So we get 1k minus 7 times 6 is 42 equals that 7 and that 7 are going to cancel. We get 3k plus 7 times 4 is 28. Okay, so again, what did I do? I looked at those denominators, which were 7 and 1. I found the least common denominator. Now I'm multiplying everything in that equation. You multiply everything in that equation by 7, and now I have this much easier looking equation to solve. Now it's got variables on both sides. I got 1k here and 3k here. Which is smaller? 1k is smaller, so I'm going to subtract 1k from each side. And what am I left with? Negative 42 equals 2k plus 28. All right, I'm going to have to rewrite it over here because I'm out of space. Negative 42 equals 2k plus 28. All right, so now I have that two-step equation. Opposite operations in the opposite order. Instead of multiplying and then adding, I'm going to subtract and then divide. All right, negative 42 minus 8 is going to give me a negative 60. And then I'm going to divide that by 2, and I get negative 30 is equal to k. All right, so the answer is k equals negative 30. And if I were to take negative 30 and put it back in that original equation, both sides should have the same solution. Let's see if it works. 1/7 times negative 30 minus 6 is supposed to equal 3/7 times negative 30 plus 4. All right, so if we take a look here, this is going to be negative 37. Unfortunately, checking this is going to involve us going back to that common denominator, right? So if my denominator is 7, I'm going to make this 42 over 7. And then what do I get? Negative what? Negative 72 over 7 on this side. And over here, I'm going to get negative 90 over 7. And this right here was a 4, and that's 28 over 7, and when I do that, I also get negative 72 over 7. So checking these, I have to admit, checking them is going to be a little bit more of a complicated process because we have the fractions, especially because 30 was not divisible by 7. So a lot of times, your answer will be divisible by your denominator, and it will simplify better. All right? Okay, let's do this last one with fractions right here, and then we'll move on to decimals. All right, 6, 2, and 4. So I'm looking for my least common multiple, or my least common multiple of 6, 2, and 4. What is the smallest number that 6, 2, and 4 are all factors of? All right, well, 2 goes into 4, but 4 doesn't go into 6. How about 12, right? Does 6 go into 12 evenly? You betcha. So do 2 and 4. So 12 is my least common multiple, or in this case, if I were finding the denominators, it would be the least common denominator. So what am I going to do? I'm going to multiply everything by 12. I'm multiplying both sides by 12, but that involves me using the distributive property here. All right. Now again, I've got 12 divided by 6. Well, 12 divided by 6 is 2. So this part becomes 10y right here. Well, there's no denominator here, so I get 12 times 1 is 12. All right, 12 divided by 2 is 6, right? But then I get that negative there, so this is negative 6y. 12 divided by 4 is 3, so this one becomes 3. All right, so again, what did I do? I found the least common multiple of 6, 2, and 4, or the least common denominator, if you're looking at these as fractions. I multiplied by that number. Remember, you're dividing by whatever the denominator is, and then multiplying by the numerator. So now I have 10y plus 12 equals negative 6y plus 3. So now I have my standard equation with variables on both sides, but the rational numbers are gone. So what's smaller, 10y or negative 6? Well, negative 6 is smaller, so I take away a negative 6, but remember, subtracting a negative is the same as adding a positive, so I get 16y plus 12 is equal to, those ones cancel, 3. Now I'm down to my two-step equation. I'm going to subtract 12 from both sides, and I get 16y is equal to, well, 3 take away 12 is going to be negative 9. And then I divide by 16, and I get y is negative 9/16. Now, if you're going to, well, wait, you got a fraction answer. That means you must have made a mistake. All right, well, it is entirely possible, ladies and gentlemen, that you're going to get a fraction answer when you started with fractions as your equation, right? So, but you know, it does give me a little bit of pause. I'm going to go back through these steps again and make sure I did not make a mistake. So I've got 6 and 2 and 4. Well, 6, 2, and 4 all go into 12. I multiplied by 12. All right, so then I got 60y because 12 divided by 6 is 2. So that was 10y plus 12 equals, all right, a negative half of 12 is negative 6y, and 12 divided by 4 is 3. Then I added 6y to both sides, so then I got 16y plus 12 is 3. All right, then I'm going to do the opposite operations in the opposite order. Subtract 12 from both sides. 3 minus 12 is negative 9. 16y is negative 9. So I divide by 16, I get negative 9/16. By the way, if you do get a fraction answer, you should always try to simplify it. But this does not simplify because 1 would be the common factor here. There is no common factor other than 1. All right, if I really super duper wanted to be sure, I would plug that back into my original equation and check it. But for the purpose of this video, I am not going to do that. Okay, now remember, a rational number can be written as a fraction, right? Decimals can be written as a fraction. That is, unless they are an irrational decimal, which would be non-terminating and non-repeating. But we're not going to have any of those. All right, so I'm not going to read through this problem, but if you read through the problem, they ended up with this equation here. Okay, 0.2r plus 0.75 equals 0.5r. All right, so I'm going to write that equation over here. 0.2r plus 0.75 equals 0.5r. Now, what do we have here? We have an equation with variables on both sides. So if I did it just like I've always done it, I'd say, okay, here's my variable terms. Which one is smaller? 0.2 is smaller. So I subtract 0.2r from each side. I get 0.75 equals 0.3r, right? And then I would divide both sides by 0.3. All right, and then I got to say, okay, well, if I'm not using a calculator here, then I got to do 0.3 into 0.75. You guys remember the process? We move the decimal over one that way, and we move it over one that way, so we actually get 3 into 7.5, right? And when we do that, well, 3 goes into 7 2 times. Bring down the 5, 3 goes into 15, put that decimal there, and we get 2.5, okay? And there's absolutely nothing wrong with that method, just like there was nothing wrong with finding a common denominator and doing that. All right, but you'll see right here what they did was they said, okay, well, I've got tenths here, I've got hundreds here, I've got tenths here. If you don't like the decimals, just like you didn't like the fractions, with the fractions you multiply by the least common denominator. All right, with a decimal, if you want to make it go away, you multiply by, if you want to move the decimal one place, you multiply by 10. So to eliminate tenths, multiply by tens. To eliminate hundredths, multiply by hundreds. To eliminate thousandths, multiply by thousands. It's actually what we did to get from here to here. We actually multiplied both of them by 10. All right, you've been doing that since elementary school, but you didn't know what you were doing probably. All right, so when they multiplied everything by 100, again, they did it to everything. They did it to both sides, right? So they did 100 here and they did 100 here, right? But then they distributed that 100 to both of them. you end up with 20r plus 75 equals 50r. So it's a little bit nicer because you now don't have those decimals, right? So now if I were to solve this, well, 20r is smaller than 50r, right? I end up with 75 equals 30r, and then I divide both sides by 30, and I get r is equal to 2.5. Now, I'm going to be 100% honest with you. I don't think that one is that much better than that one, especially if you're allowed to use a calculator. Okay, so if you want to call this one yucky, this one is maybe slightly less yucky, but it's still not great. Okay, so I'm going to be honest with you. Most of the time, decimal equations, I just solve them with the decimals. All right, fraction ones, there is definitely an advantage to eliminating fractions, especially because many times you have a calculator that won't do fractions. All right. But with decimals, honestly, there's really not a huge advantage to eliminating the decimal. All right, so last one we're going to do here in this video. Logan has 2 aquariums. One aquarium contains 1.3 cubic feet of water, and the other contains 1.9 cubic feet of water. The water in the larger aquarium weighs 37.44 pounds more than the water in the smaller aquarium. Write an equation with variables on both sides to represent the situation. Then find the weight of 1 cubic foot of water. Let me show you something, guys, here that you might not be aware of. I'm going to click on the personal math trainer right here. All right, and it is a very similar problem. Let's say you were stuck right here and you didn't know what to do. We can go ahead and click View Example. I'm going to be honest, I was feeling a little lazy, so I decided to let them do it here. Here we go. So the weight of the water in the larger aquarium for this example is 1.8x, and the weight of the water in the weight of the water in the larger aquarium equals the weight of the water in the larger aquarium. There we go. So 1.8x equals 1.6x plus 12.48. So there is my equation with decimals. Now again, I could solve it simply the way it is. 1.8x equals 1.6x plus 12.48. I would then simply subtract the smaller decimal term from both sides, right? And then I would get 0.2x is equal to 12.48. And then I would simply divide both sides by 0.2. Okay? And again, the old way of doing it, if you're not using a calculator, which of course, guys, you are welcome to use a calculator, would be to move the decimal once that way and once that way. Really what we're doing is multiplying both of those numbers by 10, which does not change the answer, right? All right, well, 2 goes into 124, 62 times, right? And then 2 goes into 0.84 times, and you get 62.4, okay? So notice, not 60.24, Mr. Reeves, 62.4. I got that answer simply by working with the decimals that were there. Now, they said, okay, I need to move the decimal 2 places. All right, that's tenths, that's hundredths. If I want to eliminate all the decimals, I multiply by 100 because that will move everything. I get this equation here. All right, now let me ask you, all right, is it really that much easier to do that one versus that one? I don't think so. I don't think so. And when you're done, guess what? You get the same decimal answer. So it's up to you what you want to do here. All right, my recommendation is when you come across these problems that have fractions, Mr. Reeves, not fractions, fractions, okay? I would multiply this equation by 4 before I solved it. I would multiply this equation by 10 before I solved it because 5 and 10, the least common number would be 10. I would multiply this equation by 11. These ones here, I would do them just like they are, and if I needed to, I would use a calculator. All right, when you get into upper division math, the higher up you go in math, the less and less and less decimals you see. When you see decimals, it's more in applications, okay? for real life math like percents and money and things like that. But when you're actually doing mathematics for mathematics' sake, right, you see fractions. Decimals really go away. All right, so there you go. That is the introduction to this lesson on equations with rational numbers. I'll be making a second video where I just work through some more practice problems for you. All right, have a great day, everybody. Till next time. Bye.